friends and students. Once again, welcome back. So we are into the second part of the PCB design. Okay. In this part, we will design a PCB. I will tell you step-by-step process with a software called PADS. It's an old software, of course, but we will learn. You can try with any of the open source software. There are so many other software which are available in the market, or you can find it on the web and you can try. The process is almost same. The step-by-step process is almost same. So we will design a PCB with the help of a software. Okay, before going into that, you should know history of the PCB design. That is, previously, we used to have a very simple method. That is the manual method, we used to call it mask. That is, we used to have create a photo mask on a clear mylar sheets. There was a sheet like this thing, and we used to create those things. And the marking is to be done, and the manual drilling were done. Okay, so the printing was manual, everything was manual at that time. But now what we do all automated. That is, modern PCBs are used for manufacturing. They use a dedicated software that is called a schematic capture through electronic design automation, EDA tool we call it. Okay, electronic design EDA tool we call it as the position of the component, heat sinks, and everything. All the things are calculated. Okay, heat sink also is calculated. What will be right nowadays, because we are into new era. Wires and lands are marked. Okay, wires means that is through one side of the PCB, as I have told you in the first part, one side to another side. When you go to the one layer, from one layer to another side. Okay, solder mask, signal traces, routing, everything is done in your automated software. And finally, what we get output, a Gerber file. By getting a Gerber file, and those Gerber file we will give it to the manufacturer. In first video, I have told you what is the process of manufacturing. In this video, we will discuss what is the step-by-step how you will design a PCB. Okay, right. Now, what is the PCB design with PADS? Okay, PADS is the name of the software. It is from the company called Mento Graphics. And now it has been taken over by some other companies. It's an old software, but please remember, learn it. It's open source. You can try with any other software. Schematic first, then we will go to the board outline. Okay, so this is the process, and we will start one by one. I will just show you how to work. I have opened my old folder. In this, different type of PCB design softwares are there. But we are going to work on this software, that is PADS Logic. Okay, PADS Logic, PADS Layout, and PADS Router. These three software we are going to use. That is, first we are going to make a schematic diagram in this. Then we will use PADS Layout. In the same PAD layout, we will use PADS Router software. So how to start to do is, I will just click on PADS Logic twice. Okay, so I have just pressed PADS Logic twice. So a new page should start. Okay, 1 minute, just please. All right. So this welcome page starts. What you have to do here, the step number 1, start a new design. Okay, just double click on the start a new design, or single click on the start a new design. A new page has come. You can see here, new page has come. The outer line is your complete board. And this is your sheet. Okay, so inside this sheet here, this is the working area where you have to make the schematic. Okay, these are the tools. These are the different type of tools you can see on the top. Different type of tools are there, which will be helping you for doing or you completing your drawing. Okay, now what first part you have to do is, first thing, please remember, after that, next step, here in the corner, the add parts will be there. One button is there, just click that button. So one window starts. Here it is already given LED 1. So symbol will be there, and it will be there. Now, according to your circuit, you have to bring all the parts onto the screen. Okay. So first, I will take one LED. I will, once you have selected the LED, you just say add. But please remember here, LED, that is item or part name, it should be the LED, and after that you should have a start. And one more thing, the library here, there are different type of library, but you just, my suggestion would be you select only all libraries. So it will find out from that, because we are putting star over here. So that's why it will put, it will find out from this library. So let's take this LED. What you have to do to bring this LED onto the screen, you have to, what you have to do, add, right? Okay, I have added the LED here now. Okay, so likewise, you different parts. Suppose now the LED has to go to, what you will do, you will just press ESC. That is on your keypad corner. There is escape button is there that you have to press it so that it goes off. Now we'll take the second one. So instead of LED, I will write here LM7805. It's a regulator. I'm making a regulator power supply, so it's a regulator. Okay, I will just type it here. This one or this one, which one you want. National company, just take it and you bring it onto the screen. Okay, again escape. All right. Okay, this is done. So likewise, you have to bring all the components. Like suppose I want diode, simple diodes or rectified diodes. So I will write DIO and I will just press OK. So diodes have come, common diode or this miscellaneous diode I will take, I will say add. Okay. So how many diodes I want? I will make a bridge rectifier. So I need a 4 diodes. So I will just say 4 diodes. Okay. So 4 diodes are taken. Again, escape. This thing will go. I need some resistor and capacitor also. The same thing, resistor and capacitor, you have to write. RES. So it will come. The resistor means how many wattage resistor? I need 1/4 watt resistor. That is quarter watt resistor. I will say add how many resistor? 2. 2 clicks and then escape. Same thing for capacitor also. So capacitor will also come here. Electrolytic, non-electrolytic depends, right? Okay, I need electrolytic. I will say add. You have to select add. 2 capacitors I have taken. Escape again. So my parts have come over here. I will just close down this and I will go to the next step. So I hope you understood. By selecting the add component, I brought all the parts over here. Now I have to arrange it. Okay, one by one I will arrange it. So that means just click on it, arrange it properly here. Okay, this will come over here. Okay, right. Now I will just alternate. It will not alternate. Again, alternate. Right. Okay. 90 degrees. Again, it is not correct. 90 degrees. 90 degrees. Not correct. So Y mirror. I will just try. Yes, it is okay now. Okay. So I will just keep it here. I will take one more resistor. Again, this resistor will. I will just move it to 90 degrees. How you have done it? You just click on the part and you just click on the right click on your mouse and it will come. Okay. So right. Okay. I can adjust it here, little this thing here properly. I can adjust this little properly. If you are want to increase the size of the screen, just on your this thing, you can just go for page up. Okay. So it will zoom like right page up and page down, that you can use simultaneously with your fingers and you will find it. Okay. So diodes and all everything you can just put it on one side. All arrangement you can do it. So what the next step is, I have to give connections. So what I will do is, with the I've taken the parts, the next button, it's a giving connection. That is add connection. It is there. Okay. So I will just press that button and I will just start giving the connection. Achha, before giving the connection, please remember everything should be in order and you should give connection point to point. Point to point in a sense, what I will do is I will zoom it again. Okay, page up, I will do it. Okay, so suppose I want to give from D2 to this connection, D2 to D4. So I will start, click it, then end, click it. Okay, so on your mouse, you can click here and end, you can click it here. Okay, so same thing, you can just keep on giving the connection for all the components according to your circuit. Please remember, you have to make circuit on a paper first before giving the connection. Okay, so one number goes to the positive end of this, then this resistor goes, one end goes to this point. Okay, and capacitor also, I will give connection to this point. So likewise, I will just go and give the connection. Okay, right? Okay, I will give connection from here to this capacitor directly, so that in between all the components can be fixed. Okay, I will give connection here. I will just move this part here. You see here. So again, go back to this arrow. Okay, and just move this part over here so that it comes in a line. Okay, right. Okay. Now I'll give the connection. Connection again I have taken. I will give connection from here to here. Sorry, pressed it. Okay, this area I will give from negative. I will give connection from here. Give connection from here. I will just turn it. Turn. If you want to turn it, please remember again you have to click it. Okay, this is the done. Now this negative connection, all the negative connection, I will give it here, here, and here. Correct. This also connection I have to give it. Now I have to make the symbols. Symbols in the sense I have to show that this is ground point. So what you do is you be there in the same mode, that is add connection mode, and just put a wire over here. Make a line. Okay. On just make a line. Don't finish it out, or just click right side, and you will find ground and power and all. Right. So you just click ground, and I will just fix it, bring it to the proper position, and this thing. So click it. So my schematic diagram is done. Now what I have to do is I have to give the values, right? There is a question mark over here. I will double click on that. Sorry, I'm still into the same thing. Okay. So I'll go to the arrow mark, double click. You have a question mark over here. What is the value? Suppose it is 100K. 100K. Just give it. Okay, 100K. I will write 100K. Click on that. You can see it has 100K. Same thing here also, right? That is nothing but attributes of the properties. Then here I will say 330 ohms because ohms only, but ohms value will not be there sometimes on your this thing on your keyboard. So just write 330 ohms, 330 only. Okay, right? 330 has come. So likewise, you have to give parts number and everything. It will be there. Suppose this part doesn't have that value. So what you will do? So I double click on the part, visibility, they go to value and tolerance, and just say okay. Close it down. You can see that question mark has come over here. So I will just double click on the question mark. I will write down the value. What is the value here? Suppose I'm taking 100 microfarad. So again, mu is not there. So you can write mu and F. Okay. 100 microfarad. Same ways you can change this also, right? So I hope you understood till this. Okay, I will show you the next part. I have already given the connections. I will just tell you how I've given the correction and all. This is 4 diodes, that is bridge rectifier. These are the 2 input, that is I've written here 7.5 to 18 volt AC input, and I've given 5 volt regulator. Of course, the number has been given here, and all the values I have kept it here. Okay, right. Now, suppose you get a doubt that how to give this number, right? That is how to write it. So what you do is, on the right hand side, somewhere in the open area, just on your mouse button, left hand side, and just you can find add fields. Okay. When you go to the add fields, you can write in the name section here. You can write whatever you want to write. Suppose I want to write, say about this is input or output. I will write output. O-U-T, output. Right? I will write output and I will just say okay. So what happens, this thing, it comes over here. Okay. So suppose this point I'm just keeping here. So it is over output. Okay. So likewise, you can just write down about the things and all, and you can take the things and all. Okay. So what is the next step after this? Please remember. So after this, making the schematic diagram, go to file, and you have to prepare a report. Okay. Before report, if you want to create a PDF also, you can just create a PDF. To create a PDF, you just press that button. Okay. It will get a regular PDF, save. Automatically that PDF will come. Okay. Okay. Then you will see the PDF also. See the diagram has come in the PDF. Again, go to file. You have to prepare reports. Okay. Press on report. Whatever reports you want, bill of material report, connectivity report, or parts report, you just select it, what reports you want, and you just say okay. So reports will be generated. Why these reports are important? Why? Because in the coming future, you will have the complete idea what parts you have used, what connections were there, how many nets were there, how from where to where you have given the connections. So this is a part list. Okay. Right. Files which you make it like when you press that file button, no? So this is the file, bill of material file. So this is one of the file. I will just show you the another file. I will just stop share this file and I will take another file. This file is about part statistics. So like you can make different type of files. Okay, please remember you can make different type of files. So these are made. If you want to save these files, you can save it for your further future. That means future, if you want to for a reference and all, you can keep these files. Okay, so this is important part. That means you are generating a file and you have already, I told you that we have to generate a netlist also. Okay, how to generate the netlist? That will be the coming. You generate the PDF, you got the idea. Now, next and the final thing, what you have to do is to go to tools, okay, and final is layout netlist. You can find netlist here. You just press on the netlist. So it will say output file will be stored wherever you want. If you want to change the file, you can browse it. Okay, wherever you want, you can keep it and all. If you want to keep it on the same place, I will keep it on the same tape. Why? Because it is given a desktop. So I will just say okay. Okay, right. Again, the netlist and everything will be generated. All the files, what we have seen before, that information, all it will be generated. If you want to save it, you can save it or you can avoid it also. Okay, so this is done. The first part is done. That means your netlist has been made. Whether it has been made or not, whether really it has come or not on the screen, how to see that? I will just put it down. You can see here, I have opened it. So you can see there's two files here. That is when we have to confirm whether the file have come or not. This is a regulator.asc file and regulator.err file. Okay, so these two files has to be there. That means your first job is over. Okay, apart from this, you can see, I will just try to show it to you also that I will stop share this. All right, so this is the file. That is PDF file. We have made a PDF of it. So three files here we have seen. We can save it in any folder or you can save it on the desktop. I've just, so this is one file, ERR file and ASC file. These two files are very, very important for us. And please remember, we will also see if this is not possible, if the video is becoming lengthy, so we will make two parts of it. That in the second part, how we will generate how this schematic will be transferred, this files will be transferred to the second software that is called as layout software and the rotor software, and there we'll make the complete PCB, how exactly the PCB outcome will be there. So that will be probably see in the second part, please. Thank you for watching and please subscribe to my channel.